properties of exponents. And the first property is dealing with fractions. And it's when you have the same exponent or the same variable over itself in a fraction raised to different powers. The way you would apply the property, you would write the base one time, and then it's the top power minus the power on the bottom. And it sounds more complicated than it really is, but we'll run through some examples in a minute. And then the next fraction setup is when you have two different variables in a fraction applied to this or raised to the same power. So you would simply distribute the power to both top and bottom, both each term in the numerator as well as each term in the denominator. Next up we have the negative exponent. If I have an exponent that's negative, in order to make it positive, you just simply put your base on the other side of the fraction bar, or you write the reciprocal of the base. It still stays raised to the numerical power of the exponent, but the sign on the exponent becomes positive when you place the base on the other side of the fraction bar. And then anything raised to the power of 0 is simply 1. And if you have a base raised, so here we have something raised to the power of 0, simplifies to 1. And then a base raised to the first power is just that base itself. And let's run through a few problems together. So I ask you to do the odds. Let's look at a few evens together on the video. If I have a problem like number 18, and number 18, I have r squared times s to the 4th times t, that's my numerator, and my denominator is r squared s to the 1st times t cubed. Now you can think of this in a simple way as this is r times r, and I have 4 s's and 1 t. That's my numerator, just written in an expanded form, just to show you how the property works. So that's just my fraction, each factor written out in its expanded form. And you can see simply that 1r on top can divide out with 1r on the bottom, leaving you with a 1. And I have another pair, top and bottom. When I remove them, I have a positive 1 left behind. I have one s on top that can match up with the s on the bottom, leaving a positive 1 behind. And I have one t on top that can factor out with one t on the bottom, leaving behind a positive 1. So then your simplified answer would be s on top raised to the power of 3, t on bottom raised to the power of 2. If I apply the property to this, the property is saying that I would write the base one time, so we'll do the r, and it's the top power minus the bottom power. And then I write the base of s one time, and it's the top power minus the bottom power, so that would be 4 minus 1. If I write the base of t one time, it's the top power minus the bottom power, so that's simply applying the properties. And when I come back behind to simplify and clean this up, well, r to the power of 2 minus 2 is r to the 0, and then I have s cubed and t to the power of negative 2. So applying all of the properties, r to the 0 is really 1, s cubed is fine as it is. If I need to write the t to the negative 2 so that the power becomes positive, I simply place t on the other side of the fraction bar. So the way I've simplified it, it's over 1 at the moment. If I write 1 over t, or simply place t in the denominator, the number 2 doesn't change, but its sign becomes positive when I place it in the denominator of the fraction. So that's taking all of the properties and rolling them into a single problem. Let's look at number 20 together. 39 and 52 share no factors, so we'll leave those as they are. And I have x cubed on top and x squared on bottom, so I have 3 x's on top, 2 x's on the bottom, and I have a pair of y's on top, 1 y on the bottom, and 1 z on top. So just thinking of this simply as removing factors that can cancel each other out or divide out to leave behind a positive 1. I have an x on top and an x on the bottom, leaving behind a positive 1. Another pairing that leave behind a positive 1. I have 1 y on top that can match up with 1 y on the bottom. And then what's left? 39 over 52. And I have one x on top. Z had no partner on the bottom to divide out and leave behind a positive 1. And I also have one y left on top. So my simplified answer would be 39xyz as a numerator with 52 on the bottom. And let's do one that's a little bit more complicated. If I have a problem like, I will leave all of the odds for you. If I have a problem like number 24, the first thing I need to do is apply my distributive property with the exponent. So take the numerator and the denominator and clean them up. So first I have to apply the cube to each term on top. This becomes a to the 6th. That's my numerator. And now I'm squaring each term in the denominator. 5 squared times a to the 6th. And you can see that I've got, in this particular problem, 3 5s on top, 2 5s on bottom, a to the 6th. So that means that I have a 5 that would divide away and leave a positive 1 behind, another pairing that would leave a positive 1 behind. I have a to the 6th over a to the 6th. So I have 5 remaining on top. I write the base of a one time, and it's the top power minus the bottom power. Just so happens that they're the same. So that gives me 5a to the 0. Well, that's really just 5 times 1, and my final answer becomes 5 for this problem. Moving to a problem set where you have different variables in the numerator and the denominator. Let's look at a problem like number 18. So this just simply says, let each factor inside the denominator, both the numerator and the denominator, they all get raised to the power of 3, and then you simplify. So this would be c cubed over 125. So you're just simply applying or distributing that exponent to both numerator and the denominator. Let's look at a problem like number 22 where you have more terms. So each term gets squared. Everything gets squared. So my numerator becomes 4 squared m squared. My denominator becomes 7 squared. N is already squared, so it becomes n to the power of 2 times 2, n to the 4th. And then you end up with 16 m squared over 49 n to the 4th. And that would be your expansion or your simplified answer. And that 4 is an exponent. Should be smaller. That becomes your answer for a problem like number 22. And then a problem like number 28. Apply the cube to the first fraction first. So that gives me 3 cubed and z cubed and y cubed. So you can see each term in the numerator and the denominator take the cubic. And then I'm multiplying this by 2yz over 15. And 15, I'm going to write this so that it's really simple. I have 3 times itself 3 times. And 15 is really 3 times 5. So when I'm cleaning this up or simplifying it, I have a factor of 3 and a factor of 3 that can be removed from the problem. And so that means that my coefficient on top is 9, and I have to multiply that 9 by the 2. So my coefficient in the numerator becomes 18. My coefficient in the denominator is the factor of 5 that was left behind. And now, combining my variables, I have z to the 3rd multiplied by z to the multiplied with z to the 1st. So that gives me z raised to the power of 4. And I have a y on top, and I have 3 y's, y cubed on the bottom. So let's clean up the y's. I still have 18 z to the 4th and 5. And I have 3 y's on bottom and 1 on top. When I remove those, you can think of it as y and then 3 on the bottom. When I factor out 1 y on top, dividing it out, leaving behind a positive 1, I have a pair of y's left on the bottom. So my simplified answer becomes this: 18z to the 4th and 5 y squared as my denominator. And there are several different ways you can get from the beginning of a problem like number 28 to this final answer. But you always have to distribute the exponent to each term, numerator, denominator. And then whenever you start cleaning up same base, powers on top, powers on bottom, raised to the same variables, there are several different ways to do that, and we can compare some methods in class. And then finally, rewriting so that the exponents are positive. This is pretty simple. A problem like number 36, to rewrite this so that the power on n becomes positive, it would simply be 2 over n raised to the third. So the number 3 itself doesn't change, but by writing it on the other side of the fraction bar, the negative sign goes away. And a problem like number 42. This would be x raised to the power of negative 6, but you need to write it so that the exponent is positive. So you write the reciprocal of the base, which is 1 over x, and then the number 6 doesn't change, it just becomes positive when it's written on the other side of the fraction bar.